So hello everyone. So in this video we are going to be seeing a constant approach for climbing stairs. We have already seen the recursion, the memoization and the bottom to top approach, but in this video we are going to see a constant memory method. So basically it's a upgrade of bottom up approach. In bottom up approach we used to make a vector, and using the last two index we used to calculate the current index. So for every time we are looking at the past two index, so what if we can just save the past two index into a variable, no need to go through all that big vector. So yeah, that is the whole idea behind the climbing stairs uh, constant memory approach. So yeah, here I think you know what happens in this position. It's like a stairs where you have to find what are the number of ways we can climb. So for if you are in the first step, then yes, there's only one way to climb it. If there's two, then there's only two way to climb it. And this one and two are actually the base case of our problem. So yeah, let's look at that. Let's first of all write the base case. Let's suppose our number of stairs is less than equal to 2. Let's suppose if we have only one stair, then we will return 1. If we have only two stairs, then we will return 2, which means if n is less than equal to 2, then we just gonna return the number itself, that is n. Now let's make our base conditions, the starting initial base conditions, using which the forward indexes are going to calculate themselves. So yeah, so first of all I'm gonna name it previous one, previous two, just to be precise. Previous one means just previous one, previous two means previous of previous one. So and previous one is going to be the first index, that is one stair only, and where there is only one way to go through that. And previous of 2 is equal to 2. For two indexes there is only two way to jump. So let's start our loop. Now from where the loop is going to start? Loop is going to start from I is equal to 3, because we have already calculated 1 and 2. For I is equal to 3, I less than equals to n and I plus plus. Using the previous one and previous two, we are gonna calculate the current, and current is equals to previous one plus previous two. Now this is the current, that is the sum of the previous two elements, that is our answer. Now we need to actually move forward with the answer, not answer, a vector, because in memoization method, sorry, in bottom up approach method, when we made a vector, so we used to for each index we used to calculate the last two index. So for every loop the index was going forward, therefore last two index were also going forward. Therefore we need to change here variables as well as the index is going forward. So the previous becomes previous, that is previous of 1 becomes, sorry, previous of 2 becomes previous of 1, and previous of 1 becomes, okay, why am I making it end again? Because it has already been initialized before, so there is no need for it. And previous of 1 become current. I think this was the whole point, and we just gonna return the previous of 1, that is our current answer. Let's try to run it. So we are getting an error, return, okay, spelling typo error. Okay, now let's try to run it. I hope this works. Okay, this works. Let's try to run it. Wrong answer at n is equals to 4. Let me check. mm, this is good. This is good. Current is okay. The sum of last two index is okay. We increased it. Do I need to? What were the stress cases? I think I was able to find the problem because previous should be 2 1 and previous should be 2. This is the reason why I was failing. Now this is going to work. Yeah, it worked. Thank you.